In this video here, we're going to have a discussion on the prediction of Unit 5 Physics, IAL. This is a IAL prediction paper. So we're going to look at some of the concepts that you really need to prepare as far as the exam is concerned. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. So we are going to look at these units: thermodynamics, radiation, oscillation, and cosmology. This is A level. This paper is going to be 90 marks, and it usually take 1 hour 45 minutes. One of the questions that you really ought to be prepared to answer is a question. For instance, here, candidates were told to analyze this, and the radiation detector is placed near a radioactive source, and which of the following emitted by the source? Remember, when there was no obstacle between the source and the detector, the count rate was 850. Paper was placed is 850, so meaning the radiation passed through paper. Aluminium, it became 150 from 850, and the lead, it became 20. So which means that there were two types of radiation. Alpha was not there because it could be able, the radiation that was available could pass paper, so meaning alpha is not available. And since part of the radiation was stopped, some few radiation was stopped by aluminium foil, it means that now this could have been beta and gamma, because you can see when the lead sheet was there 20, but when aluminium was there it was 150, so meaning that some of the radiations was stopped by aluminium. That was the value decreased, and we shall say the answer is D. There could be a question in pendulum consisting of a mass. We are told the acceleration of the mass A is and displacement is plotted. Which graph represents? Remember, in simple harmonic motion, acceleration is directly proportional to displacement. However, acceleration is directly proportional to displacement. However, something that you ought to remember is that one is the opposite, is in acting in opposite direction. So acceleration and displacement are directly proportional, but they act in opposite direction. So which means the gradient of their graph is going to be negative, and also the line is going to be passing through the origin, which means that acceleration and displacement are directly proportional. That's why the line passes through the origin. But also, for that reason, since acceleration and displacement are directly proportional and they are in opposite direction, that's why the gradient has to be negative, and the line has to pass through the straight line, has to pass through the origin, and has to be a straight line. So that's exactly what you are supposed to respond in that question. So moving to the next question here. Question number 3, radioactive source emit alpha radiation, beta radiation, gamma radiation. Which is the correct one? Which of the following is correct? We need to remember that alpha radiation is most ionizing because it has a greatest mass. So if it has a greatest mass, it means it can be able to knock electrons from the surface of any atoms as they pass through. Beta radiations are penetrating, the least penetrating. That's false, because we know the least penetrating is alpha, followed by beta, and the most penetrating is actually gamma. Beta radiation is the most ionizing. That's false, because we know it's alpha, and then gamma radiation is the least penetrating. That's false. So we were supposed to discredit that and move to the next question. A space shuttle of mass m returning to Earth of mass m, and this returning to Earth of mass m, and the space shuttle falls from a height r above the Earth, where r is equal to the radius of the Earth. Which of the following gives the change in gravitational field strength? So we are going to say change in gravitational is going to be 1 over 2r minus 1 over r. But since this negative is here, is going to make this to be gmm 1 over r minus 2 1 over 2r, and that's going to be basically option A in that case. And moving to question 5, which of the following should, because we are told that the student investigate absorption of gamma radiation, he measured the background radiation. Which of the following should he do to correct the count rate? In order to correct the count rate, he has to subtract the background rate. Yeah, he has to subtract the background rate, not background count, because we are correcting a rate, we are correcting a count rate, so you have to subtract a background count rate. Yeah, so question number 6 was a question from simple harmonic motion and a damping motion. So which of the following statement is correct? Damping force is always in opposite direction to velocity. Damping force is always in opposite direction to velocity, so that that force can be able to reduce the velocity of the object, because we know as damping, as a material continue oscillating, the velocity keeps on decreasing. But therefore, that means the force, that means that the force must be acting in opposite direction to the velocity of the object. Moving further to question number 7, there is an electric field around a point charge and the gravitational field around the point mass. Which one of the following is not correct? Both are radial, that is correct. Both can produce attractive forces, because when two masses are placed next to each other, the force is always attractive. The gravitational field created is attractive for any masses. But for charges, the electric field can be either attractive or repulsive, depending the type of charges that are available. So we can say both field can produce, that's correct. Both fields can produce repulsive force, no. Masses will never produce repulsive force, because gravitational force or gravitational fields are only attractive. Yeah, so moving to question number 8, a student finds the diagram to, you notice that the labels of the axes are different. Use this textbook, and we can see a HR Russell diagram here. In this HR Russell diagram, we have the highest level here, the topmost here, we have the red super giants. We have the red giants, so we need to identify these are the red giants. And then we have the main sequence and the white dwarf here. So the correct order is G, O, M, and A. So because we know this towards this region here, hot, and toward the up, this part here, we have cool stars, and brightness increases as you're moving up, because when there is high luminosity, it means that it's more bright. So the answer for this particular arrangement was supposed to be D. In that case, D is the correct answer there. We have question 9. Boyle's law states that under certain conditions, the pressure exerted by a gas is inversely proportional to the volume occupied by a gas. Which of the following condition not necessary? Condition not necessary is the molecules must be identical. It's not necessary, but gas must be ideal. Kinetic energy of the molecule must stay constant, and the number of molecules must stay constant, because if this changes, it's going to affect the pressure exactly, because if the kinetic energy is high, if the kinetic energy of the molecule is high, it means high kinetic energy, it means high pressure. And also, if the number of molecule increases, it means that the pressure also is going to increase, because there will be more collision per unit area. And what must be also ensured is that the gas must be ideal for the laws to apply. Lastly, we have question number 10. For fusion, we have to ensure that for fusion we have high density and high temperature. High temperature for the molecules to have high kinetic energy to increase chances of collision, and high density is to ensure that the particles are a bit packed, so that there are high chances of the nucleus colliding. So you gonna sit for this paper and you'll have the first 10 question multiple choice, and then from there you'll have the rest of the paper from question number 11 being structured questions, explanation, and also calculations. So let's see what you really need to understand. Also, you need to understand the use of specific capacity, latent heat of vaporization, latent heat of fusion, because those questions might be asked. You need to understand also how to define the specific capacity. Specific capacity, the amount of thermal energy required to change the temperature or to change 1 kg of a substance by 1 degree Celsius. So in question number 11, we have an electric kettle containing 4.25 times 10 to the power 4 water and the temperature of 22 degrees Celsius. The kettle is switched on for 85 seconds to reach a temperature of 100 degrees Celsius, which is actually the boiling point of water. And now the power of the kettle is show that the power of the kettle is basically this. So it's quite interesting that they want us to respond to this question. I think what you needed to remember is that mass is equals to density times volume, so that you can be able to use the volume that was provided and the density that was given here to get the mass of water. Now, once you have the mass of water, what we need to realize, once you have the mass of water, you can be able to work out the amount of thermal energy involved in this case. So therefore, at this particular point, I worked out the mass, and then I said thermal energy is given by MC change in theta, mass times specific capacity times the temperature change, whereby the temperature change is 100 degrees Celsius minus 222. And if you work out, the energy will be 1386.21 joules. But we are asked to work out the power. We know power is energy supplied divided by the time taken. So in that case, it will be the amount of energy that we have gotten in the previous question here, divided by the time, which was 85 seconds. And if you work it out, you are going to get the answer simplifying to 1600 watts. Water boils at 100 degrees Celsius. Calculate the time taken for 75% of the water to boil away. So for us to calculate the percentage of water, time taken for the water to boil away, the first thing that as a student you are supposed to do is to calculate what is 75 kg, 75% of the total mass of water that was available here. So once you have calculated that, you will get is 0.318 kilograms as the amount of water that is going to vaporize. But we know thermal energy required to vaporize this is going to be MLV, mass times latent heat of vaporization. And that is basically going to be 0.318 times the latent heat of vaporization. And if you work it out, you'll get your final answer or thermal energy required to be this. But now, since we have worked out power from the previous question, and in this case, we have worked out power, then we can be able to use that for this formula, time is equals to energy over power, so that we can be able to get the time taken. So you'll take the energy required, divide by power for you to get what? For you to get the time taken, which is 441 seconds. Question number 12 is a question from simple harmonic motion. So which means you might be asked a question to do with simple harmonic motion. But first, you need to understand what do we mean by simple harmonic motion. Simple harmonic motion is the type of motion where force is directly proportional. It's the type of motion where acceleration is directly proportional to displacement, but they act in opposite direction. But how does that graph show that? The graph being a straight line indicates that acceleration and displacement are directly proportional. That's the first thing. And number two, since the line is a straight line and passes through the origin, implies that acceleration and displacement are directly proportional. But since the gradient of the line is negative, it means acceleration and displacement are in opposite or act in opposite direction. So when you are supposed to respond, you see the graph is a straight line through the origin with a negative gradient. What does that mean? That shows that acceleration is directly proportional to displacement, and they are in opposite direction. So basically, that's what you are supposed to respond in this particular question for you to earn all the marks. Now let's move to the next question so that we can see what else can you be asked. You are told calculate the maximum kinetic energy. Now, for you to work out maximum kinetic energy, you need to know what is the maximum velocity. Now, in that, we are going to say this graph that we are having here basically is acceleration is directly proportional to is equals to omega squared x. This is the relationship that is connected by this. So if you're going to work out the gradient of this line, we have to have a negative here, so that it means this is B, so that it means that so that it indicates that they are in opposite direction, the negative sign. So whenever you are going to get the gradient will be negative. So you are going to say negative omega squared is equals to the negative gradient that we have here. So once you've gotten that, you can be able now to find the square, because gradient is a negative, and this is negative omega squared. So meaning omega squared is equals to the gradient positive values. Now, you find omega by finding the square root, but remember that maximum speed is equal to angular frequency times the amplitude. Amplitude for these graphs, you can read the maximum displacement is at this mark. Yeah, so that's our amplitude is this value. This is our amplitude. So you can be able to work out maximum speed using the angular frequency that we have gotten here and the amplitude. Then we can be able to get our maximum velocity to be this value that we have here. Now, for us to work out maximum speed, now we are going to use this value, this formula that we have written here. I have mv squared, and if you work it out, you're going to get 3.49 times 10 raised to the power 3 joules, and that is the units for that. The graph for kinetic energy is shown here. This is how the graph is, and the graph is going to be at 3.49 here. And of course, as displacement increases, kinetic energy decreases. So which means as you're moving across, as you're moving towards the amplitude, velocity decreases. So that's why you can see as you're moving from kinetic energy is going to decrease. We move to new this particular question, whereby we are to show the energy released. So something that you need to remember here is that mass of reactants minus the change in mass, or mass defect, mass lost, is equal to the mass of the reactants minus the mass of the product. And that is exactly what I did, because the reaction was between polonium, which led to lead plus alpha. So meaning this is the reactant, yeah, and then this is the product. Yeah, this is the products. So which means that we are going to take the mass of polonium, we subtract the sum of lead and alpha for us to get that. And if you work it out, you're going to get 8.67 times 10 to the power negative 13. We are told that 98% of the energy from the decay is released as kinetic energy of alpha particle. So here you are supposed to calculate the velocity of the alpha particle immediately after the decay. So quite interesting, quite simple here. You are supposed to work out what is the kinetic energy of the alpha particle. What's the kinetic energy of the alpha particle? So 98 over 100 times the value that we had gotten here, that's going to give us 8.5 times 10 raised to the power negative 13 joules. And then we know that kinetic energy is equals to a half mv squared. If you rearrange this equation and make v the subject, the formula, you're gonna find, because remember the mass of alpha is already given here, so you can be able to use that mass down here, and if you work it out, you get 1.6 times 10 raised to the power 7 meters per second. Yeah, so Explain why not all energy from the decay is released as kinetic energy of alpha particles, because some energy is carried away by the lead nucleus, or some energy is released in form of gamma photons. Yeah, so basically that's what we're supposed to do. Also, we have this question whereby we're supposed to show that 1U is about this. So we know 1U is 1.6 times 10 to the power negative 27 joules, is it? Kg rather. But energy is equals to a half mc squared, which means that, energy is equals to change in mass times c squared. Our change in mass is this value that we have there. And then the speed of light is 3 times 10 to the power 8. And if you work it out, you get in joules like this. But we know 1 EV is 1.6 times 10 to the power negative 18 joules. So for you to convert it to mega electron volts, you're going to divide by 1.6 times 10 to the power negative 19 times 1 million, because we are converting to mega. So which means that we have to divide this by a million. And if you work it out, you're going to get 930, approximately 930, because the answer, if you put it inside your calculator, you will get your answer, which is probably 933.75. If you work it out now, you try to convert, or sorry, to round off, you're gonna get 930 as the final answer. Francium nucleus and alpha particles move away from each other after the decay. Explain why kinetic energy given to alpha particles is just less than this. So you are supposed to respond on that question as shown here. So because of the interest of time, I'll move and take you through how to answer question to do with radioactivity, and question to do with decay constants. Whenever you have half-life, you can get the decay constant by saying ln of 2 over the half-life, and that's going to be ln of 2, but the half-life, you have to convert it to seconds. And then once you have that, we need to work out the activity. Remember, activity is equal to negative decay constant times the original number of nuclei. And then, which means that for us to get the original number of nuclei, in this case, the original number of nuclei in this case, which we are going to use somewhere here, we are going to say is the activity, which is the activity was given, divided by the decay constant that we had gotten. So if you work it out, the number of nuclei atoms originally that were present will be 9.13 times 10 to the power 13. Now, for you to find the number of atoms or nuclei remaining after a period of time, you're going to use the formula remaining number of atoms is equals to original number of nuclei or atoms, e raised to power negative of the decay constant times the duration. And the duration has to be in second, because the decay constant was given in seconds. So which means if you substitute, you have to get around 5.6 times 10 to the power 13 atoms. Until next time, you can be able to access this paper down below so that you can be able to proceed down. And I'll also attach a marking scheme together with it so that you can be able to proceed and get to see how to work out the rest of the questions. All the best for those who are going to sit for this particular exam. I wish you the best of luck. And also, once you're done with the exam, just come back and let us know, was these questions helpful? Did they were you able to get questions related to this, so that we can be able to get to see whether this was of help? See you in the next tutorial.